Oh yeah, it's time for acceleration day 2. Just in time for the apocalypse, we have some new memes. This looks like they've repurposed the stonks guy into acceleration. That's now a new meme. That's great. Enjoy the memes for a second before we move on to learning. We're going to continue with acceleration today. Ka-chow! Okay, so acceleration is a change in speed over time. All right, so we're looking at this. Looks like somebody's trying to drop a penny off the Eiffel Tower so they can take out somebody on the ground. Now, remember, Mythbusters has proved that a penny that falls even from the Empire State Building doesn't really hurt anybody. It's more of an annoyance. And I was up on top of the Empire State Building, and they have guards there making sure you're not chucking stuff off. Anyways, when we're looking at this, it's wanting us to solve for time. So I've started with a little bit tougher problem. Now, what do we know about this? Well, we have acceleration is equal to VF minus VI over time. Now, this question makes this a little bit tougher because it wants to solve for time. And you might be like, wait, I don't have enough stuff. We talked yesterday how the acceleration due to gravity is 9.81 meters per second squared. So anytime something falls, the acceleration is always 9.81. This is a little bit tougher problem. There's nothing like this you guys are going to have to do, but just from that standpoint. Now, the velocity final is what the penny lands with, 75 meters per second. Before you drop a penny, how fast is it going? It's not going fast at all. It's going 0. Now, this height of the building, we're not going to use. So what we have to do is solve for time. How long is time? And if you remember from yesterday's lesson, we can do a little switch-de-switch to change the acceleration and the time around. So time is equal to VF minus VI over acceleration. So if we put our numbers in there, 75 meters per second, subtract 0 over 9.81 meters per second squared, we can now solve for how long it takes the penny to fall. So 75 divided by 9.81 gives me about 7.6 seconds. We'll go to 3 digits, 7.65 seconds. So it is a little bit trickier problem. Anytime something falls, its acceleration is always 9.81. And that's actually a negative number because you're moving down. That's okay. That's all right. We don't need to worry about that. But I just thought I would show that if you know how fast something is, maybe you've got a speed gun at the bottom, you know, one of those radar guns that figures out how fast cars are going, you would be able to calculate how long it took the penny to fall because everything on Earth falls at that speed. So it wouldn't even matter if you threw like a chicken. Well, I guess a chicken might be able to float down. Anything, I don't know why you're chucking stuff off the Eiffel Tower. But anyways, you know what I'm getting at. Okay. So as a recap, I'm just going to give you guys these formulas. For the assignment that you're working on today, and it's due the first day you guys get back from the break, that's the acceleration formula. And you can rearrange it by moving the time and the acceleration around and putting acceleration on the bottom. Those are the two formulas that you need. Now, we're going to briefly look at one more non-uniform motion formula, and it looks like this. It's in your data booklet. There's a whole bunch of extra formulas in your data booklet, and because we're doing kind of this emergency teaching, Mr. King and I, we've decided to just limit the formulas that you guys need to know for acceleration to the main acceleration formula and this displacement non-uniform motion formula. So you can see it looks kind of bizarre. Instead of solving for acceleration, it's solving for displacement. And we're adding the two. We're not subtracting them. We're adding the two. So as long as you have everything in this question, you can solve for how far something went. It's kind of cool, actually. It's a really cool formula. Okay. All right. Let's try it. How far did a clown run if it changed its speed from 14.5 meters per second to 22.3 meters per second for 3.2 seconds? Now, we've gone through a couple formulas. Like, for example, if you remember, we've done the speed formula, we've done the velocity formula, and the acceleration formula, right? Now, if I was trying to solve for distance, maybe we could rearrange these guys, but the problem is we've been given two speeds. So we need the two-speed formula. And the two-speed formula looks like this. Velocity initial plus velocity final over 2 times time. And I know I need this two-speed formula because I've been given two speeds. So how fast was the clown going initially? 14.5 meters per second. All right. And we're going to add that to 22.3 meters per second. You might say, how do I know I'm going to do that? Well, if we're setting up our toolbox, the velocity initial is 14.5 meters per second. That's how fast the clown was going. The final, as the clown changed its speed, it got a little faster, 22.3 meters per second. And our time is 3.2 seconds. Okay. So setting this up like the formula, I'm going to have my time on the outside. Now, how do I put this into my calculator? Well, if you don't have a fancy calculator like me, and you can't see mine, but it's a graphing calculator, we have to do everything inside the brackets first. So I would go 14.5 plus 22.3. I would press equals, and I would divide that by 2 and press equals. So if you're following along on your phone or a calculator you have at home, I would go 14.5 plus 22.3 and then hit equals and then divide that by 2. Inside the brackets, you should have 18.4. And then we're going to times that by 3.2. That way we don't mess this up and try and do it in one big step. We're doing everything in the brackets and then multiplying by 3.2. And I get around 59. And what are we solving for? How far the clown ran. 59 meters in that time. So the clown's booking it. But remember, clowns are soulless killing machines. Okay. Here's another one. A clown has run 90 meters. Initially, it had a speed of 3.45 meters per second, and it slowed to 2.45 meters per second. How long in seconds did it take to run 90 meters? Okay. So we have two speeds, so we need the two-speed formula. All right. Now, let's write down everything that we know. Okay? Let's write down everything that we know. So we know, in this case, we know how far the clown ran, 90 meters. The initial speed of the clown is 3.45 meters per second. The clown slowed down. Maybe it was approaching its kill. I don't know, 2.45 meters per second. What we don't know is time. So we're going to have to rearrange this formula for time, and that's going to be a little bit tricky. I didn't put a question like this on your assignment, but just to give you an idea, we can solve for time here. Okay, how do we do that? Well, if this side is being divided by 2, let's times this side by 2. The 2's cancel, and the 2 comes over to this side. Okay. Now I'm going to rearrange this. So I'm just going to rewrite this. Not rearrange it. I'm going to rewrite this. So I have 2d is equal to vi plus vf in brackets times time. Now, what's the opposite of multiplication? The answer is division. So I'm going to divide this side by vf and vi. So they're going to cancel. And what I do to one side, I have to do to the other. So it goes to there. So when I rearrange this formula, time is equal to 2d over vi plus vf. Okay? So basically, that's our formula. And then now we can just plug our stuff in there. One more time, if I rewrite that formula, okay, it's a vi first, plus vf over 2 times time. 2 is on the bottom, so guess where 2 goes on the top? VIVF is on the top. It goes on the bottom. Do you see how you can just switch stuff around to rearrange? It's kind of cool. Okay. All right, so let's throw the numbers in there and call her good. So 2 times distance, we had 90 meters. And VI is 3.4 meters per second. And VF is 2.45 meters per second. Okay. Now, I need to do the brackets together, right? You need to do everything in the brackets first. So I can do the top, 2 times 90. That's fine because it's not going to affect the bottom. 2 times 90 is 180. Over, and I'm going to add the bottom first, 3.45 plus 2.45. That gives me 5.9. 180 divided by 5.9 gives me around 30.5. And what did I solve for? Time. What's time measured in? Seconds. Okay. Now, there is one question on the assignment that uses this formula. Okay? You'll notice it. It's one of the questions that gives you 2 different speeds. It's a tougher question. But now you have one more formula to add to your arsenal. And it looks like this. Distance is equal to VI plus VF over 2 times time. Okay, please come to the Google Meets if you're having trouble with that assignment. Okay, that's what we're working on today. Nothing new but the assignment from yesterday. Keep working through it.